Dear students, now we will be demonstrating the next experiment, which is the inverse square law. So what you see over here is a selenium photocell. You can see the photocell is fixed over here and a multimeter is connected. So you can see that the red cable or the red lead is going to the microamps or milliamps knob, and the black lead is going to the common port. And here presently the knob is set at 2 milliamps. We will check if this position is fine. If not, then we will either move below or move higher to a higher range. You can see there is a small triangle at this knob which tells us that the current position is at 2 milliamps. So that's all about the selenium photocell. And now what we have to test is whether this photocell follows the inverse square law. So as you know, the photocell operates on the principle of sensing light energy. So when photons fall onto the cell, it produces a current which we can measure on the ammeter. So we have a light source, which is the lamp here. Let's plug this in. So as soon as the light shines onto the photocell, you can see that some value of current appears. And when I change the distance, I'm bringing the lamp closer to the photocell. What you see is there is an increase in the value of the current. So that's exactly what you will be doing in this experiment. You will be changing the relative distance between the photocell and the lamp and record the corresponding current in the circuit. You will have to take the readings from, so you can see the photocell is here and a mark has been made. So treat this as the starting point. So right now that starting point is aligned with the 35 centimeter mark. So if I put my lamp marking at 25 centimeter, then that distance is actually, you can say that the relative distance between the photocell and the lamp is 10 centimeters. So you start from here, and for every 1 centimeter, you keep shifting the lamp and change and note the change in the current. So as I'm moving my lamp away, I can see that the current in the photocell is reducing. Likewise, when I come at the 10th centimeter, which means my lamp is at 15 centimeter, the current which I am observing is 0.305 milliamps. You may consider to shift this knob to microamps in case the distance for which you are keeping the lamp far away from the photocell. Now hence you see this one, that means for the present setting, the range of 200 microamps is insufficient, and hence I would prefer to keep my knob at 2 milliamp position and then complete the experiment. So in summary, what you have to do is you have to change the relative distance between the photocell and the lamp and take the readings for distance, change the distance by 1 centimeter and record the corresponding current. After that, you will have to plot two graphs and do the analysis and infer what you understand, whether the photocell follows the inverse square law or it does not. Thank you.